ladies and gentlemen. I'm Dr. Mark Brandon. I'm the president of Princeton Adult School, and I welcome you to our first lecture in our Diamonds Are Forever, our first 75 years. This is a very special year for the Princeton Adult School. As many of you know, hopefully all of you know, this is our 75th anniversary, and we are celebrating it with a number of events. Usually at the start of each semester, I've asked a question which I know would probably be accurately answered tonight, and that is how many of you have already spent at least one semester with us? But I'm not going to ask that question, because I know that's a large majority. We had in this room a week ago Sunday, the very first of all of our events for the 75th anniversary. Was a conversation that was chaired by Charlie Gibson from ABC News, and had 4 college or university presidents, including our last 2 Princeton University presidents. It was a great event. And I would just wonder how many of you who are here tonight attended that conversation? So a good number of you. Let me be perhaps the first then to tell you that we have 2 more conversations coming up over the course of this year. One in December, which will be on the general topic of politics. We're going to have a number of former United States ambassadors in the conversation. And then in the springtime, date to be determined, we're going to have one about the arts. And I think both of them are going to be fantastic. So please go to the brand new web page, princetonadultschool.org. I've got it up there on the board for you, and you'll be able to keep track of all of that information. My wife was good enough to be selling T-shirts up there. You see, I got one on, and a number of other members of the board and our helpers have them. And we do have a few of those up there. If any of you want to purchase them afterwards, we are offering for the special adult school price of $15 tonight. There will be no lecture on October the 22nd. That is the week that midterm exams occur here at Princeton University. This room is usually used by a professor to administer an examination. If any of you want to take that examination, you're welcome to come. There will be no lecture. We will be having a lecture though the following week, which is the break week, where the undergraduates are away from the university. But in keeping with the thought of these feed your curiosity and celebrating the adult school 75th anniversary, I would like to present as a gift from the adult school one of these to our speaker tonight, and I'll just be back here. I'm going to turn the lectern over now to Maru Walliser. Maru is right over here. She is the co-chair of our lectures committee, a member of our board for many years, and she was formerly the director of the program in teacher preparation here at Princeton University. She knows an awful lot more about Princeton than I do. So Maru, here you are.
Good evening, and welcome to the first gem in Diamonds Are Forever, which is the title of this series, as you may remember. Our speaker tonight, Professor Cecilia Rouse, is currently Dean of the Woodrow Wilson School for Public and International Policy. I can't see through my glasses. She is also the Lawrence and Shirley Katzman and Lewis and Anna Ernst Professor in the Economics of Education, and that's a mouthful. She is the founding director of the Princeton University Education Research Section and a director in its Industrial Relations section as well. In the larger world, she's a member of the National Academy of Education and a research associate of the National Bureau of Economic Research. She has twice served Democratic presidents, first in 98-99 as a member of President Clinton's National Economic Council, and more recently as a member of the Council of Economic Advisors for President Obama between 2009 and 2011. That may give you some clue as to her interests and her research focus. She clearly is interested in education and labor economics, and she's done groundbreaking work on the economic benefits of community college attendance. She's done a study of unions in South Africa, the effect of financial aid on college matriculation, and my favorite, the role of gender bias in orchestral auditions. And yes, there is a lot of bias, and it's very pronounced. Dean Rouse earned her bachelor's degree in economics, of course, at Harvard. But she also played flute and the piano in the university orchestra. She studied both French and Farsi and helped start wine tasting sessions at her undergraduate dorm. She stayed on to earn her PhD in economics in 1992 at Harvard, after which she immediately joined the Princeton faculty. And she told me just a few minutes ago that she gave her first adult school lecture in 1993, so welcome back. This evening, she's giving us another aspect of her wide range of research interest, talking about the work of another Princeton professor, Orley Ashenfelter, and evidence-based policymaking. Now, Professor Ashenfelter is not only an accomplished labor economist, but also well known for his work on wine. So that's how he brought her interest. Please join me in welcoming Dean Cecilia Rouse for this first tech talk in our series. Thank you.
So I'm getting feedback, but is that because the other one's still on? Okay. We good? Shall I wait a minute? Is that off? Okay. Well, thank you very much. It's a pleasure to be here. It is indeed the 20th anniversary. Thank you. 20th anniversary since I was last here, and I still remember my adult school talk then. It was about, is American education truly in crisis? So you can see I haven't moved far off of my interests in 20 years. But this was, it's a pleasure to be here tonight. The prompt for the talk was, think of somebody or someplace who's had a fundamental impact on your field in the last 75 years. And as I hope I will convince you in the next 45 minutes or next hour or so, that one of our very own, Orley Ashenfelter, has truly had a huge impact on not just labor economics, but microeconomics in general, and that has had a spillover into policymaking as well. And so that's my challenge, and let's see how well I do. Okay, so first of all, who is Orley Ashenfelter? So I wrote that he's a California native. I think he was actually born in North or South Dakota, but he grew up in San Diego, where I grew up as well. That's one of the things that he and I share. He went to Claremont McKenna Men's College, where he met his wife, Jenna. He received his Princeton PhD in 1970. This was back in the days when, well, not back in the days, but Orley got his PhD in 1970. You have the sense that they had to get him to finish his PhD so that they could give him tenure, because he was already a professor and he was a full professor 2 years later. Yeah, that wasn't the timeline I was on. But that just to tell you that he was a wunderkind, and you know his professors and everybody really understood just what a phenomenal economist he was. Today he's the Joseph Douglas Green Class of 1985 Professor in the Economics here at Princeton. As I mentioned before, he's married to Jenna Ashenfelter, and importantly, he's the father of Tracy, Bevan, and Jillian, and I don't think you want me to forget that. So that's Orley. That's basically who he is. I'm going to focus on one aspect of what he's contributed, but really he has contributed important papers and insights in a variety of fields within economics. So I think his earlier work was in the economics of labor unions, including arbitration and bargaining. And in full disclosure, while the resemblance isn't very strong, I'm actually Orley's, in terms of professional life, I'm actually both his great-granddaughter and his granddaughter. And I wrote my senior thesis on grievance arbitrators because of one of his students, David Bloom. And so this is part of what I'm going to talk about. Orley's, his legacy is really his students, and his students and so on. So he's contributed much to labor unions, which, you know, labor unions in the 1960s were very important in the labor market. Today, not so much. So Orley has branched out. He's also done important work on unemployment, on discrimination, on labor supply, labor demand. Many of you may be familiar, as Maru just mentioned, on his work in wine economics. He has a newsletter on liquid assets. But what I really want to focus on is his work in education and training and how he has really revolutionized how we do empirical work in economics. His career highlights include that he was director, I'm going to come back to this, the director of the Office of Evaluation at the U.S. Department of Labor from 1972 to 1973. He was editor of the American Economic Review from 1985 to 2011. So you can imagine that was quite a tenure as editor of the very top journal in economics. He was president of the American Economic Association. I was going to go without saying. He's a fellow of the Econometric Society, the American Academy of Sciences, and importantly, he was director of the Industrial Relations section from 1971 to 1995, and then the directorship started to rotate, so then you see him coming in and out. I could easily have made this talk about a thing, and that thing might have been the Industrial Relations section. And so I'd be remiss if I didn't give a nod to the people who helped form Orley, because Orley's not an island. He didn't just pop in here and make his great contributions to economics. Rather, he was really a product of the Industrial Relations section and the faculty that were here when he was a graduate student here. And so the Industrial Relations section was started in 1922, I believe it was, with a gift from the Rockefeller family. And J. Douglas Brown was not the first director, but he was the first director to really enhance it. And J. Douglas Brown was someone who was an expert in industrial relations, so labor management relationships. And importantly, he also spent a lot of time in the academy. Not only was he a professor here, he went on to be dean of the faculty, but he also spent time in public service. So public service, from the very founding of the Industrial Relations section, was an important part of its mission. Then we had Frederick Harbison, and more recently we have, many of you may even know, Dick Lester and Al Rees, who really were in the section and at Princeton at a time when large microdata sets were starting to become more widely available, when computing was starting to become less expensive, and when we were starting to have statistical techniques to allow economists and other researchers to analyze that data. And both Al Rees and Dick Lester, I think it's Dick Lester, brought in Al Rees to really sort of push forward the use of these data to answer questions not just theoretically, but to say, well, what do the data have to tell us? What are the empirical facts behind what we might know about the labor market or not? And that was very formative for Orley. He was there, he learned from those faculty members, he participated in projects of theirs, but what I would say about Orley is he's actually a very good theoretician as well, but what he's really done is said, how can we use data to learn more things about the world? And I would be remiss not to mention Bill Bowen, who was actually a faculty associate of the Industrial Relations section as well, and went on to be president of the university, and went on to collect a lot of data even after he left Princeton, and was answering a lot of important questions, especially in education policy. So all of that was a very rich environment in which Orley did his graduate work, and his entire career has been here. So why did I choose him as someone who has transformed labor economics in the last 75 years? Well, for three reasons, really. So first, he's really championed the use of econometric techniques, and I wrote on my slide here, transparent. Because if you're going to try to use data to answer questions about policy, if it's a really complicated statistical analysis, so that you basically have to, when the person comes up to tell you about the result, that person has to first give you a lecture or maybe a whole semester on statistics in order for you to understand it, the message gets lost. So what Orley was really after, what he's championed, is transparent, relatively simple econometric techniques that allow you nonetheless to get good answers on the effectiveness of different policies, of evaluation of policy interventions. He's also really encouraged creative data collection. One of the things that is a hallmark of Orley and many of his students is that they don't just analyze data that are collected by the national government or by some other entity, but we go out and collect our own data as well. And so we use surveys, we do our own surveys. Actually, for my senior thesis, I did a survey of grievance arbitrators, and that was very much encouraged by my thesis advisor, David Bloom, who had been a student of Orley's here. And so through his work and that of his students, he's basically changed the way that we do microeconomics, and I'm going to show you fundamentally how that started, and I hope it's going to be transparent enough. But I have to admit there's little statistics here. And it has changed really, it's filtered its way into policymaking. I'm not going to make the claim that all of this was all Orley, but I can tell you from the economic side, a lot of it was Orley, and we can probably trace it through. Okay, but to tell this story, I've got to go back to 1972. You can tell I had a little fun digging up the old pictures of Orley. All right. So in 1972 and 1973, Orley spent a year at the Department of Labor, where he was director of program evaluation, as I just mentioned. Now, the fact that the Department of Labor even had an office of policy evaluation tells you that they were interested in understanding whether policies are effective or not. In fact, that office disappeared, I'm not actually sure when, and then in the Obama administration it was recreated again for the first time in many, many years and decades. So already back in 1972, the Department of Labor was already interested in understanding the effectiveness of policy, and Orley really took that to new heights. So while he was there in particular, he was struck by the fact that at the time, the US was spending about $2.5 billion on job training. If we were to inflate that number to today's dollars, that's about $13.2 trillion today. That's a lot of money. If we were to compare that to what is being actually spent today, it's about twice as much as it's more than twice as much as we currently spend on job training today, at least through the Department of Labor. So we were very much invested in training individuals. So this is post-high school. These are individuals who may be down on their luck or may lack skills for another reason. And the idea is, well, if we give them job training, it helps to improve their skills, and it makes them more employable, and it should improve their outcomes. So he said that's a lot of money, right? That's what, $13.2 trillion in today's dollars, $2.5 billion back then. And so Orley said, well, what's the value of this program? Is it actually effective? And the critical part was, how do you define whether a program is effective? How do you define whether a program is valuable achieving its goals? So now we need to take a step back. So what Orley argued was, and I think this is what we've now understood today, is, well, a job training program is designed to increase your skills. The reason we try to increase your skills is so that you become employable. So therefore, we should see that if the program is effective, that those who participate in the program should have higher earnings, should have higher rates of being employed than those who don't participate in the program. I'm actually going to make that a harder question. I don't want to just say, do those who participate in the program have higher earnings? Are they more likely to be employed than those who don't participate? The question really is, do those who participate do better than had they not participated? Right? So that's really the question that's going to be at hand. Now the problem is that in order to answer that question, you need a few things which can be difficult to obtain. One is, for statistical reasons, in order to have a small enough margin of error that you're not just saying, well, the program might have had an impact of nothing, to having increased earnings by, $200 a month, which is a really big, wide margin of error. That's anything from, and we could even go negative, right? And you could drive what we say in the business is, we could drive a truck through that margin of error, and because it's a little bit meaningless. It's just so wide. So in order to have a smaller margin of error, you need to have a big sample. So where can we find large samples? It's also, if we really want to know, so individuals participate in training today, and then the question is, how do they do in the labor market tomorrow or the next year or the year after that? You actually have to follow individuals for a few years. And so that can be costly to interview. You not only have to keep track of individuals, people move around, you also have to hire people to go interview them. So that can be costly. The part that Orley really is known for the father of is he really challenged us to say, but what's the counterfactual? Now, what do I mean by counterfactual? What I mean by counterfactual is that question that I posed at the very beginning for how we're going to evaluate this policy, which is we want to say, what would have happened had that same individual not participated in training? So you can imagine that if we were omniscient, the way we would do this is we take a group of individuals and watch them live their lives for the next, let's say 2 to 3 years. We're going to watch these individuals live their lives, and then because we're omniscient and all-powerful, We have a time machine, and so we roll them back, make everything exactly the same as it was before, but this time we're going to have them enroll in the training program, and then see what the outcome, how the outcome with the training program differs from that without the training program. Right? So that is ideally what we would want to do. And the reason why we want to do that is because by looking at the same individual with or without training, we can try to distinguish between two different interpretations of any outcome. Suppose we were to find that those who participate in training actually do have higher earnings after 2 or 3 years than those who didn't participate. Well, there are a couple of explanations potentially. There are probably more, but I'm going to stick with 2. One is that the education or training actually provided them with skills that were valuable. And so therefore they increase their training. So that's a good thing. We would say there's a causal impact, therefore, of the training program on the individuals. But it's also possible that those who choose to participate in the training program, so let's think about this. So we have a training program, it's a national training program, it's not going to take that many people. Those who are all, typically you have to be kind of down on your luck enough, so your income has to be low enough, or you haven't been employed for very much time in order to be eligible for the training program. So among those who fit that criteria, who has got the information to go and enroll in the training, find out about the training program, get themselves together to enroll in it, and get themselves to the training program in the first place? So the concern here is that those who participate in the training program are very different from those who don't. And if that's the case, then if we observe that there's a difference in earnings later, that might not be due to the training program at all. It just may be that if you are smart enough and motivated enough to find out about a training program, figure out how to enroll, and go to the training program, you would actually have done pretty well without the training program anyway. And that's the big concern, is what's the counterfactual? Did you actually need the training program to do better, or did the training program actually make you better? So that has been the big challenge. Now, I described ideally we'd have this time machine. There's another way we could do it that we think pretty close, which is we could also conduct a randomized experiment. So in a randomized experiment, what we're going to do is we're going to say, take a group of people who are all eligible for the program, and then we're going to hold a lottery. Sometimes they literally, for charter schools, sometimes they're literally on TV holding a lottery, where they pick out who's going to participate in the training program and who will be in what is called a control group. If you're lucky enough to be selected for the training program, you can go to the training program. If you're selected for the control group, well, you can participate, you can enroll in any other training program, or go to school, or not go to school, or do whatever you're going to do, but you don't get the extra boost of being eligible for this, being able to participate in this other training program will do for you. Because it was just the luck of the draw that distinguishes the two groups of people, it's not whether you were motivated or connected enough to know about a training program, it's just that you were lucky. And it's because that's the difference that distinguishes the two groups, we think on average it's going to tell us something about the causality of the training program. Okay? Have I lost you yet? No, you're with me. Good, all right. So on average, that's the beauty of a randomized experiment. You can think about, we do randomized, the FDA and in medicine, it's very common to do randomized experiments. And the analogy there is that if you go to your doctor with a headache, and your doctor prescribes some drug, you don't want to just take the drug if your headache was going to resolve in the same amount of time that the drug would do it. You want to know that the drug was going to make you feel better faster than what would happen otherwise. And similarly, in trying to evaluate these training programs and other social programs, the question is, does it make people's lives better than if they hadn't done it at all? Okay. All right, so we could do these randomized experiments, and one of Orley's legacies is actually pushing the use of randomized experiments to understand social programs much more aggressively. But he understood at the time, and many other people we still understand, that while experimental data are really, many people say the gold standard, I'm going to tell you they don't answer all questions, but nonetheless I think they're an important part of our toolkit. But what do you do if there's no experimental data to be found? Do you just give up on using evidence to determine whether programs are effective and help guide policy making? Or do you look for another way to try to replicate that same kind of way to understand the training program? So what Orley proposed, again, remember this was at the time when large data sets were starting to be computerized and made available electronically, and the cost of computing was coming down. So what he proposed was using data from Social Security Administration, right? Even back then, everybody had to submit their, they had employment taxes, and so employers were submitting data to the Social Security Administration. We had Social Security, all that's got to be submitted so we can determine what everybody's benefits are going to be over their lifetime. And he was in the federal government, and he thought, the federal government's sitting on these perfect data. Why don't we try to use them to learn something more about government programs? An advantage of Social Security data, it's a lot of people. Another advantage of Social Security data is you get measurement annual earnings, for those who are in the labor market at least, over time. So you get repeated measurements on earnings. So he had large numbers of individuals, so he had the large sample sizes. And then, okay, I just said to you, the problem here though, is that those who choose to, and then what he did was he matched the Social Security data with data from Department of Labor on who actually participated in training. But our problem here is that those who were in training chose to be in training, whereas those who didn't chose not to. So what he kind of argued is, okay, well that's true, but I've got some information in the Social Security data that could allow me to disentangle these. So I can match them. I can look at trainees who are the same age as those who are not trainees, who are the same sex, and he had other limited characteristics. And so this is what he did. So an obvious way to use these data, so what this is a graph of the earnings difference. Let me see if I can do this. Okay. So it's the earnings difference between the trainees and the non-trainees, so the comparison group. For each year, now the training program was in 1964, and so he's going to start in 1964 and follow it for several years thereafter. So it's the difference. So when it's positive, it means that those who were in the training program did better than those who were in the comparison. So the fact that it's a big negative number in 1964 is not that surprising. They were in a training program, for goodness sake. They weren't working. So you would expect that the trainees would do less well than those who were in the comparison. So that's fine. And then what he finds is that the year after, ooh, look at that. And for 1, 2, 3, 4, 5 years afterwards, those who were in the training program had significantly larger earnings than those who did not. So this is great news, right? This looks like the training program generated higher earnings for those who participated in the training program versus those who did not. The problem is we're starting to look at the trainees in 1964. Suppose we were concerned about, we said, well, actually we've got data on how well they were doing before 1964. So suppose we were to start matching them even earlier. Because if we really think they're identical, then their wages should be the same before they're in the training program. Some of them were in the training program, it dipped down, and then they did better, right? That makes sense. Okay, so what happens when he did that? Well, so when he went back 2 years before, that's really close to zero. So that's a zero, that difference, we call that zero. So 2 years before, those who participated in the training program actually were looking pretty identical to those who did not. But look what happened 1 year before they participated in training. Those who ultimately participated in training were doing less well relative to the comparisons. And then you saw that dip down that we had before. This is while they were in training. And then you had a rebound. This rebound's not quite as big. This pattern, where the trainees look pretty similar, if you go far enough back, they look pretty similar to the comparison group. And then those who get the program start to look less well right before they participate, has become known as the Ashenfelter dip. And it has been documented in many other contexts as well. First of all, it's been documented in not just this one training example, but in other training programs as well. It's actually, you can find it in educational examples, you can find it in almost any program where those who are eligible for the program have to be down on their luck. Question? So this is the difference. So I've already subtracted them out. That's why if it's positive, that means that the trainees were doing better. See? So I tell my students, every question's a good question. Yes. So this Ashenfelter dip poses a bit of a conundrum. Because what it means is, why is it, the question that it poses is, why is it that the trainees were starting to do less well? If we thought that, okay, really they're identical, then here the trainees are just kind of randomly doing less well, but on their own, their earnings were going to recover, then it wasn't the training program that made that difference. If, on the other hand, they look identical 2 years before, but then the trainees start to look less good, right? They're doing less well, and that was going to be a permanent difference, and the training program helped boost them back up, then that was the true effect of the training program. And the problem is with these data, we can't disentangle these two impacts. He did some work with another college, with a student of his, David Clark, who was here on the faculty for many years and now is at UC Berkeley. And actually what they documented is that while I keep characterizing that 2 years back, they look identical, you would think then that, okay, well, we're just going to skip this year and then start to look at them compare starting from here. But it turns out that the estimated impact of job training is very sensitive to what you choose as the first year, if you go back further, or what you use as a base year. And that's already telling us, therefore, using these kinds of data, we're not going to know whether we're getting the right answer or not. Okay, have I depressed you quite enough? Because there's more. Orley then had another student named Robert Lalonde, who was here in the 1980s. And Robert Lalonde got access to data from an experiment, like I just described to you would be the ideal, of a job training program that was conducted by an organization in New York called MDRC. So MDRC had run an experiment where they randomly put some people into a training program and randomly selected some people for the control group and estimated the impact of this program. So Bob Lalonde said, okay, well, what I'm interested in is we can't always do experiments, just like Orley. We can't always do experiments. So what can I do to get close to the same answer I would get with the experiment? So he did something that it seems a little counterintuitive, but actually has made many economists very famous, which is to say, well, what if I take good data and make it bad? And so what he did was he said, I know what the right answer is from the experiment. Suppose I didn't have the control group. So the only difference there is the control group. So I know who participated in the training. Now what if I did what Orley Ashenfelter did? Took the trainees and matched them with data from the current population survey, a monthly survey, that's where we get our employment numbers, from the current population survey or another nationally represented survey to get my comparison group. So I do the same exercise that Orley did, but the big difference is I already know what I would get if I did the experiment. And the very sobering part of his analysis, and this was a very influential paper in the 1980s, in 1986, is that the answer not using the experiment varied wildly. That he couldn't be confident that he was able to replicate the experiment when he was just using this other survey data to construct the comparison group. So this paper made everybody very, very depressed in the mid-80s because it really said that non-experimental data, the kind that's really readily available and most of us mere mortals are able to use to try to study lots of different phenomena, different programs, may not be giving us the answers that we think they are. So what are we to do? So we can't because we can't always do experiments. So this is where Orley really kind of started, and even more than Orley, his students started to take off. Because the reality is we can't always do experiments. We just can't. But we still need to use evidence in order to drive decision making. So what can we do? So I want to use an example that comes from education, labor market education. So, and I'll show you the ways in which economists have pushed forward to try to generate statistical analyses that replicate what experiments can do. So this is a graph which shows you annual earnings graphed against number of years of schooling. The beauty of this chart, so you can see that in the US, this is from data from 2013, from last spring. You can see in the US, there's not much of an improvement from year 0 to about 10. There are very few people in the current population survey who are in this range. Most people in the US at least get to middle school, if not the beginning of high school. But you can see starting in about 10th grade, there's a very strong relationship between years of schooling completed and how much individuals earn. So one of the great things about this chart is that all economists agree about this. They agree that that's what these data look like, and you know that that's rare. Listening to the debate about the debt ceiling, you can get 12 economists to get 14 different opinions on what's going to happen. But economists will agree with you that this is the pattern between earnings and education. but we can't always agree about everything. So we do disagree about why this happens. And this has been so fundamental economics, we've had 2 Nobel Prizes awarded for it. The first, Gary Becker of Princeton, he was the other alternative. I was thinking about doing Gary Becker as my person for the last 75 years. Gary Becker was a Princeton alum, and he did work on what we call human capital. And so he hypothesized what we've basically been arguing, or that we like to think, is that schooling, what we like to think here at Princeton, is that schooling makes you more productive. And because you're more productive, you earn more. The same argument with job training. The alternative explanation, which is by Michael Spence, who got a Nobel Prize as well, is that it's not that the education is making individuals more productive. Again, this is that alternative interpretation. But it's that those who get more schooling might be more motivated, smarter, whatever word you want to use. And that schooling is simply a signal. I mean, we hear this all the time. You know, Princeton looks good on your resume. It's not that Princeton's teaching you anything, but it looks good on your resume. And so we know otherwise. And so, therefore, you know, what it is just a stamp that Princeton admissions is doing all the work that employers don't want to have to do to separate who they think is really motivated or smart or whatever word you want to use. And then employers then are going to use that as a signal. But Princeton itself didn't add any value, didn't make individuals more productive. So Mike Spence's interpretation is called job signaling. Gary Becker's is human capital. So this is exactly the same conundrum that we are facing in the job training discussion, is what's the interpretation of the pattern? Okay, so what Orley said was, all right, well, you know, if we thought it was hard enough to do experiments where we randomly assign people to job training programs, even harder to assign people to different years of schooling, if not even. Okay, so in order to crack this relationship, we're going to have to come up with a non-experimental technique. So what are some ways that people have tried to disentangle whether it's the schooling that's making people more productive and therefore generating higher earnings versus their own ability or motivation or something that they had before they went to school? So Orley really championed an approach which has become known as natural experiments. So these are not actual experiments where we randomly assign individuals to different states of the world, but these are natural experiments. And by natural, we really mean that we're looking for situations where individuals have, say, different years of schooling for no reason, for a reason that we think is sort of unrelated to their motivation, ability, or something like that. And then we're going to relate their schooling to their earnings because we have confidence that the reason their schooling differs is not because of that unobserved ability, but for some other reason. So, 2 examples that I'm going to walk you through are compulsory schooling laws. And this was work that was done by Joshua Angress, who was a student of Orley's, and Alan Kruger, who, as you know, is one of my colleagues here at Princeton. And the other example is twin studies, which Orley and Alan, and I then worked with some data that they collected, did not champion. These actually had been done in the 1970s, but we took it to new heights. So first, let me walk you through an example of a natural experiment with compulsory schooling laws. So look at this example. This is from Ashenfelter and Kruger. Angress and Kruger. So this gives, look at birth year, so we're looking at data from a while ago. And on this axis is average years of schooling for people born, and these numbers tell you the quarter of the year, say of those born in 1930 who were born in the first quarter of 1930, the second quarter, third quarter, fourth quarter. And if you look at this chart, you start to see a pattern. That those born in the fourth quarter, okay, it's true I was born in December, but really that has nothing to do with it, have higher years of schooling than those born in the first quarter of the year. And that pattern, more or less, holds over all of these different decades. Now, what might explain that? Well, Angress and Kruger, I had fun digging up, this was an overhead from like 200 years ago. So Alan Kruger has this graphic to explain how this might work with compulsory schooling laws. So in the US, especially at that time when the compulsory schooling laws were relatively new, compulsory schooling laws worked on two fronts. One, they said you have to be enrolled in school by the time you're 5 or 6. And they said you are able to leave school when you're 14, 15, 16, 17. And importantly, over this time period, different states were starting to edge up their compulsory schooling ages. So in this graphic, what we have is two twins, Ron and Bob, who are actually named for two labor economists at Cornell. So what it says is, so Ron and Bob are identical twins, but one was born right before New Year's on December 31st, the other was born 3 minutes after on January 1st. And so the father goes to enroll them in school, and the school administrator says, no, we're sorry, but Bob must wait until next year. He's born on January 1st, and the rules are the rules. So Ron gets to start school that year, when he say is 4, and Bob has to wait for another year when he's 5. But they turn 16, say, suppose that's the year you can drop out, at essentially the same time. And so the result is they both get to drop out at age 16. For Ron, that means he's dropping out of the 11th grade, and for Bob, it means he's dropping out of the 10th grade. So it's possible that those compulsory schooling laws explain that pattern. This has been a little bit controversial, so there are some who argue maybe not, but it's a very compelling explanation for the pattern. Furthermore, this is a little bit harder to see, but if you look at the wages, so instead of average education, now I have log weekly wages. We do log just because you can get percentages that way. You get roughly the same pattern, that those born in the 4th quarter have higher earnings than those born in the 1st quarter. And if you relate the two through a technique that's become known as instrumental variables, then you get a causal impact of education on schooling. So it was very clever. Joshua Angress has taken the art of instrumental variables to heights Orley never could have imagined. He has estimated everything we might want to know about them. What are they actually telling us? What are some other ways you can use them? He's used them in many clever subjects and to address many interesting topics, and he's educated many students. But it does allow us to generate what is a plausibly causal estimate of the impact of education on schooling, of education on earnings, and you get an estimate of about 10% per year. Okay, so that would be one way in which Orley has really helped us, so through these natural experiments and the use of instrumental variables, and this is one example. Another example is through looking at data on identical twins. And I mentioned earlier that Orley's also really been the father of collecting one's own data. So in the 90s, the Princeton Industrial Relations section used to have an annual summer pilgrimage to gather data on twins. And if you want to gather data on twins, you could either be born in Sweden, where they have a twins registry, or I think there was a Minnesota twins registry in the US. Or, if you've got too much time and too much money, you can travel to Twinsburg, Ohio, and attend the Twins Festival and interview twins at the festival. So I did this once, maybe twice. And so we pile out, we can all fly out there, pile into a few rental cars. And what we would do is we would interview twins. So they're all very proud of being twins. Womb mate is the one T-shirt you'd see with a little arrow, womb mate. So you could identify the twins, and many of them were very, they didn't really have anything else to do but eat cotton candy and participate in twin stuff. So we would interview them, and we would separate them. And we would ask them lots of questions that were very similar to the current population survey, and we would get their earnings for themselves and their years of schooling. Alan Kruger had the very clever idea of not only asking each twin about him or herself, but also about his or her twin. And that turned out to be a very important insight that allowed us, with these data, to address a problem with measurement error that had haunted earlier twin studies. And the problem is that if you look at this graph, which says, what's the difference in years of schooling between twins? Most of them are lined up right here at 0. In other words, especially if you look at identical twins are, when a fertilized egg separates in utero. So they're genetically identical. After they separate, their environments are a little different. So most of them have the same number of years of schooling. So it leads you to worry that if they're different, is it because they really have different years of schooling, or did we do a data entry error, or did somebody misremember? And we call that measurement error. But if you ask each twin about not only him or herself, but about his or her twin, then you can actually start to address that measurement error. And what you can relate the difference in years of schooling between twins to the difference in their earnings, and guess what the relationship is? Very close to 10% per year for each additional year of schooling. So this became yet another approach to estimating the return to schooling. So really, as you can see here, and since then, so in economics now, people are very focused on getting a causal estimate of whatever they're trying to estimate. They use these instrumental variables in natural experiments. You have twin studies. More recently, they've developed even more techniques, like something called regression discontinuity, which I won't really discuss. But all of these are motivated and based on Orley Ashenfelter's real desire to find ways to use existing data to mimic a randomized experiment. And you can see that being used in areas like economic development. In fact, there's a lab by Esther Duflo, Esther Duflo must be a student of Josh Angers, so she's also a great-granddaughter of Orley Ashenfelter's. And so they've revolutionized how they're doing economic development. This has been used in health economics. It's been used a lot in education, which I want to show you. Corporate finance, public finance. It's really in all areas of micro and even other areas in economics. And a lot of that is due to Orley. But I made the title also about public policymaking because Orley was motivated first about evidence-based policymaking. And there's been some strides there too. Now, not all of this is Orley, but I can tell you that the Economist influence, and in fact, as I'm about to put up the next slide, this was an office created under the Bush administration, and I know that some of the education economists or education researchers who were involved in that were very influenced by Josh Angers, who was in Cambridge at the time, so I'm going to give Orley credit for this too. So, for example, here's one way in which evidence is making a big difference in policymaking today. Before the Institute for Education Sciences was created in 2002 by the Bush administration, there was something known as the Office of Educational Research and Improvement, OERI. The research done in education was known as being, well, not that helpful. And so under the Bush administration, they said, we need to stop funding research which is not giving us answers to whether programs actually make a difference for children. If we're going to be spending money, we need to understand whether a program is actually changing the lives of the children that are participating in the program. So they reconfigured their office, which was focused on research, and there was a heavy emphasis put on randomized experiments. Russ Whitehurst was the first director of IES, and he was a psychologist. Psychology has been using randomized experiments for a very long time, but there was a heavy emphasis on if we're going to be investing money in research and education, we want to actually know that it's making a difference in terms of the policy. This is also very, very related to a growing emphasis on scientifically based research in education as well. We can talk more about that. It's very controversial. I don't think it answers all questions, but it was a pivotal moment in education research. And there's just a big emphasis on establishing causality. This is my memorial government shutdown slide. This shows you between 2002 and 2009 how many grants IES has granted in terms of research. Last week, I thought I would extend that to 2013. I should have taken a screenshot, but because of the shutdown, the Department of Education's website is down, and so I could not update the slide. So you see, the shutdown has affected even you, or at least the Princeton Adult School. But anyway, you can see that the growth in grants that IES has given has grown. Again, it's reflecting that growth in importance and the focus given to evidence-based policymaking. Part of the administration, the Bush administration as well, and under IES, they created something known as the What Works Clearinghouse. And this was an attempt not to say that we're going to generate a bunch of randomized experiments, but if policymakers, and when we say policymakers, let's really talk about decision makers at all levels. In education, we're thinking then superintendents, principals, teachers, parents, anybody who's interested, not a lot of not-for-profit organizations. If you have the question, what do we know about, I don't know, computer-based algebra? Which programs are effective and what do we know about that? The What Works Clearinghouse was an attempt to say, we're not going to give you every study that has been done on this. Instead, they've got a whole arsenal of what classifies as a rigorous study on any topic, and they attempt to summarize it in a very accessible way. So the idea is if you're going to use evidence in policymaking, not only do you have to produce the good quality research, but it also has to be translated in a way that's effective. So now this is being done by Mathematical Policy Research, just down the road. And again, it reflects, and the only kinds of research that they will summarize on the What Works Clearinghouse are those done by either experiments or done by estimators that are plausibly experimental, that really generate a causal impact of the intervention on student outcomes. Finally, more recently, and in the Obama administration, there are just so many people who, and economists who really, and I'm more directly influenced by Orley, the Obama administration took this even further, and they said, we really do want evidence to be used for policymaking at all levels. And we know that you can't run a randomized experiment every time for every new program that's being developed. It's just not practical, it's infeasible. So I decided I want to start a new tutoring program for students at Princeton High. In order to get funding from the Department of Education, I have to run a randomized experiment on my little program. That's not feasible. It's just not practical. So what the Obama administration created was a program called Investing in Innovation. This originally was funded by money from the Recovery Act. And the idea was to develop tiers of programs that would be funded from this fund. And each tier, depending on where you were, would have increasing levels of rigor that had to be brought to bear on the evidence if they were going to support your program. So working with researchers and with people who are in the field, they developed these 3 tiers. So the first set of grants are called development. So I'm starting my new tutoring program, little tiny program. They will give me a small grant to help me get my program off the ground. Importantly though, even though I don't have to do a randomized experiment, I have to start collecting data. Because the idea is that if we're going to be using evidence for making decisions, it's not just the experimental data, it's all kinds of data, because that's really how we make decisions day to day. Then there's validation. So, okay, I've been running my program for 5 years, and I think I have, I can see that my students are doing a little better than those who are in my program, but it's not an experimental estimate. So then I can qualify what they call the next stage, which is a validation grant. So that's for programs that already have collected some data, and they're large enough now, the programs are large enough now, have a little bit of a track record, and now you have to then be starting to conduct your first maybe randomized experiment, but it's going to be on a small scale, almost a case study. So that's going to generate what we have here called internal validity. If I just do a randomized experiment, so now I'm big enough in my program, I'm turning away people. And so if I'm turning away people, I'm selecting them. So if I flip a coin to decide who's going to participate versus me choosing, what's really the difference? So, but now I've done my experiment. My program looks great on this, 60 people that I had in my little randomized evaluation of my case study. The next size grant is for those that are becoming much larger. And now you want to say, well, is it going to work in Trenton and in Ewing and in Somerville? Is it going to work in lots of other places? What if we try to scale it up? And so they call it scale up. And so the one thing that's so nice about I3 is it takes even this nascent idea of Orley Ashenfelter, that it's not just Orley, but of using evidence in policymaking, saying the randomized experiment or even the big study is not possible everywhere, but we think that data should be brought to bear to make many more decisions. And how can we actually implement that in a way that's feasible and doable? So, I am concluding. So, you can see that Orley really has influenced economics, especially microeconomics, empirical microeconomics, and policymaking. He's pushed our understanding of techniques that try to replicate experiments and that are used to evaluate policy in many new directions. He's nurtured many students, colleagues, visitors to this section over many years. And these students have gone on to work in areas like health economics, environmental economics, development economics, corporate finance, many other areas. And he's really helped fuel the push to bring more evidence to policymaking. So that's why I chose my colleague, Orley Ashenfelter. Thank you.
Plot up there that showed you had such scatter in the plot getting through a straight line with a positive slope. I think that any kind of straight line keep going through that data. Am I missing something?
Oh, well. what you're referring to is my return to schooling, this one. So this is ordinary least scores regression, where actually what the line is the OLS line through those data, and that line is drawn to minimize the distance between any of those points in that line. So it's not just any old line, it actually is a line that sort of correlates the relationship between the two axes.
Have you averaged out each range there?
What it does is it literally minimizes the difference between each point, so it's the best fit. Yeah.
You've got a lot of assessments happening, and the amount of assessments keep increasing each year. I'm thinking about in education. Is there any evidence at all that the amount of assessments can actually decrease the performance? At some point, you're going to be assessing students all the time. Is there any point that we're approaching that?
So, I would argue that I think that's part of the balance that we have to strike in trying to, so the assessments are not just about evidence-based policymaking. It's related, it's also about school accountability. So they're related. In my own view, I think it's possible to do too much assessment. And I think the evidence does suggest that, schools narrow curricula and there's teaching to the test. And there are different views on the impact of that on students. I think there's some evidence that, for example, teaching to the test, some would argue that it helps students who are struggling, and is it so detrimental to those at the top? I don't know that the evidence on that is the best, but we do see that there's evidence on that. I think this is what we're struggling with right now in education policy, quite frankly, is how do you strike that right balance between accountability without overburdening students with too much assessment? And I don't know that we've got the right balance right now. So I share that concern, although I'm not sure that no accountability and no assessment is the right outcome either.
In this current downturn, a lot of students with many years of education have found that they can't get really good jobs. What kind of an impact would you expect on the data as a result of the downturn?
Well, I have another PowerPoint presentation where I can show you that is true, that with this downturn, this downturn was, the way I like to say it, was more democratic than many, which is that typically when we've had recessions, the unemployment rate for those who have the least years of schooling go up significantly. Those who have, say, a college degree don't change as much. That, roughly speaking, the unemployment rates for everybody doubled. Now, for those who have a college degree, that meant it went from like 2 to 4%. Those who had no high school degree, it went from like 8 to 16%. So while it's true that the recession hit everybody, it still is true that the unemployment rates for those with a college degree were much, much lower. It's just that they normally wouldn't feel them at all. So I think the relationship still holds between schooling and earnings. What I think, schooling and earnings, I think what we saw this recession was very deep and very broad.
Well, we always have been talking tonight about aggregates and these cumulative numbers, and the individual seems to be lost in the shuffle. I came to this country in 1962, had decisions had to be made about what grade I was going to enter. And then I went through the school system in New York and continuously was fighting to keep up with everything. And I think the system failed me. I have a master's degree right now, but it took everything that I could do to get it. And I think that it has to do with accountability. It has to do with whether the teachers and the supervisors of the teachers are not just getting the kids through, but are being successful. So they are actually, should go to the next level, not just go to the next level. It's easy to put somebody from 9th to 10th grade, right? You deserve to go there. Not sure if
Well, first of all, I appreciate your comment about the fact that these are a lot of aggregate. And that's one of that's one of the aspects of randomized experiments that I think is not appreciated by all, which is they're really pretty blunt tools. So when you do an experiment, the only thing that you're learning about that's with any validity is just that one dimension that you flipped the coin over. Are you in the program or out? But especially if you have a lot of programs that are participating, some of them may have classes that are in the day versus night, or some of them have maybe more experienced teachers or less experienced teachers, or some of the students may be poorer than in other places. So there are a lot of dimensions that actually may differ, but because the only thing I flipped the coin over was, are you in the program or not, that's the only thing I can truly learn. So we call that, when there are differences across different students and different settings, we call that heterogeneity. And it becomes very expensive, right? You can incorporate all that into your design, but you've got to have little mini experiments that are large enough to do that. It's very expensive. So I agree with you that that's one reason why I think the experiments don't tell us everything. But they're a guide. I think my sister, who's here, an anthropologist here at Princeton as well, and does medical anthropology. So you can imagine, like, I'm here doing, got to randomize experiment. She's the anthropologist saying, no, it's about the people. She reminds me of this all the time. And she says, even with medicine, the experiments that the doctors work with are very blunt. They tell you, well, one group took the drug and another didn't. But then the doctors are faced with, she's done work on sickle cell patients. And the doctors are making judgments all the time about things that are a little bit off script because they know their patients. They've seen how drugs actually work in the real world or with certain patients. And that's not what the experiment, which was just very blunt, told them yes or no. So that's very much appreciated, and it's part of what we have to incorporate into this decision.
Your study that you've communicated with us about talks about hourly wages and income, but doesn't reflect the cost of getting this education, the college debt, et cetera, et cetera. Have you looked at net earnings, net against the cost, the implications being a more technical training should be needed versus liberal arts education, et cetera?
Well, I could stay for another hours. And I really do have another set of slides on just this question. So, college debt has definitely been growing. And a lot of that is not because literally the cost of educating students in higher education has been changing, but because of the way we're financing it has been changing. So in the early 1970s or so, public states subsidized about 44% of the cost of educating kids in the public institutions. Today that's down to 22% and falling. And so what happens is it still takes the same cost, so they're shifting the burden onto the families. So the federal government's taken up the slack a little bit, so there was expansions of Pell Grants, and we had the American Opportunity Tax Credit, but even that is slowly being rolled away. Pell Grants have almost outpriced themselves, and now we have is quasi-entitlement. It's not talked about much, but it's a hugely expensive program that every year Congress is scrambling to figure out how to pay for. So you see students taking out more loans. That said, for most students, the amount of loans that they're taking out are not excessive. There are the exceptions, and those, as Bill Bowen puts it, those exceptions are in the New York Times. And they managed to find them. And I'm not saying that there's none of them, but I think that, among those who borrow, so this is among those who borrow, they borrow about $25,000, $26,000 a year among all types of institutions. And for most students who get a four-year degree, they're going to be able to pay that back. For students who don't complete the degree, they've taken out less in loans, so typically they're able to, to pay them back. That doesn't mean that you take out loans ex ante, and then you may sort of get bum luck. If you were graduating in 2009, 2010, boy, that was a hard time to be graduating. And so ex post, just like any investment where you may sort of lose, it's risky. That's what I'm just saying, it's sort of risky. So, our policymakers have tried to reflect this, and so income-based repayment options and other repayment options have really grown. And so now this was just past a year or two or so. Actually, it was originally part of, well, before that for doctors and nurses, and for especially doctors that go into rural areas and other healthcare workers and teachers, there was income-based repayment from before, but that was greatly expanded under Student Loan and Financial Responsibility Act, SAFRA, which is passed with healthcare. And so most people now really could, if you really do like sort of draw that bad draw after college, you don't ever have to pay more than about 10% of your income in student loans, recognizing exactly this.
So you get a 10% bump up in income, and you're still paying 10% of your income in student loans. Is that what you just said?
No, you shouldn't have to ever pay more than 10%, and it's your income above the federal poverty, actually 150% of the federal poverty line in student loans after taking out some disposable income, some issues as well. So they try to make it that you never have to go bankrupt. Not as many people are taking up these income-based repayment options as really could be, and it's one of the things we got to get the word out about. But they really are trying to recognize that for some people, you know, they aren't quite as able to pay back their loans. But really, this horror stories you hear in the press is not commonplace with student loans.
I understand you trying to identify the relationship between A and B. But it seems to me that life, particularly in the education world, is much more complex than that. You have issues of the quality of the schools that the kids go to, the poverty level of the family, socioeconomic issues in the neighborhood, the level of education of the family, all these other kinds of factors. Have you ever tried, to look at multiple factors? That is, that A and B and C are true, and that you can correlate some combination with something?
So, you know, oftentimes, so we economists tend to be a little bit, you know, we have to keep things simple if we can. And so everything that you said is absolutely right. So the neighborhood, the quality of the school, parents, friends, all of that factors into absolutely what one's life course and one's life's outcome is. And we do look at those in general as well. But if the question is for a superintendent, should I actually get this program where my students are going to do math on the computer instead of in a classroom at the teacher talk and talk? Those are the kinds, or, you know, does school quality? So David Carter and Alan Kruger did some influential work on school quality back in the early 90s, where they were looking essentially at class size. Does lowering class size make a difference? So we tend to, with these policies, try to say, if we just affected that, what difference is it going to make in the lives of kids on average? So it doesn't mean that all those other factors aren't important, but we can't necessarily control them all at once, unless, of course, we're doing something like Promised Neighborhoods or Harlem Children's Zone, which we're trying to do now.
But if you are looking at that on average, you're looking at a whole wide range of students.
Exactly. So this goes back to my point about heterogeneity. There can definitely be different impacts for different kinds of students.
Right, so you need to tickle out, will this computer program work for kids who have
Yes.
these circumstances in their life, these experiences?
That's exactly right.
Okay.
I'd like to ask a question that's off the topic, but I think you're uniquely qualified to perhaps answer the one that Ms. Factor. And all of this audience might not know that tonight it's apparent that the president will nominate Janet Yellen to be the new president of the Federal Reserve. And can you tell us what things may be different? What should we expect to see in the next 4 years when she gets approved?
Who do you think is qualified to answer this? You know, Janet Yellen is, a friend of mine emailed me, who from Washington emailed me, I hear the sound of glass ceiling cracking, being shattered at the Fed. And it said, you know, it really is a historic nomination for a president. You know, Janet Yellen has been working in the Federal Reserve System for quite some time. She was president of the San Francisco Fed. She's been vice chair of the Federal Reserve System for the last, 3 or 4 years. And I don't know that there's going to be major changes. I think what you can expect is she cares a lot about unemployment. You know, as the Fed, you know, has these dual mandate of inflation and unemployment. I think she's viewed as being someone who puts a little bit more weight on unemployment than maybe some others. And so I think she will be watching that. She'll be watching the dial on unemployment very carefully as she's trying to unwind the balance sheet of the Fed and get out of their buying all of these, all this bank debt. So I don't know that it's going to be a major change in the course of what the Federal Reserve is doing. But you know, she's been very savvy. Her predictions have been right on. She's probably got one of the best records of the Fed governors. And so I think you're going to have a Fed chair who's very sensitive to the health of the U.S. economy. I think she'll be paying, like I said, paying a lot of attention to unemployment. And I think she'll do a great job of trying to get the Fed out of this and while keeping the American economy healthy at the same time.
I think on that historic note.